find the total distance traveled by the particle from time t equals 0 to t equals 1. Now let's remember, they didn't say find the total displacement. They said find the total distance traveled by the particle. So if something goes to the right by 1 and then goes up by 1, their distance is 2. And actually, then if they go back over here, actually let me draw a straighter line. If they then go back to the original starting point, and then this distance right here would be what? The square root of 2. The displacement would be 0. They got back to where they started, but the distance would be 1 plus 1 plus the square root of 2. So how do we figure out the total distance in this scenario right over here? And let me erase this just since it's not relevant to the problem. It's just to remind ourselves we're talking about distance. Well, distance is equal to rate times time, or it's equal to speed times time. So in a very small amount of time, if you want to figure out the distance, well, you could take your speed, which is the magnitude of your velocity function. If you took your speed, that's your speed right over there, and if you multiplied it by a little small change in time, that's going to give you your infinitesimally small change in distance over that infinitesimally small change in time. And if you wanted to change if you wanted to find the total distance over a non-infinitesimal change in time, well, then you can integrate. And you can integrate those little changes in time, in this case, from t equals 0 to t equals 1. This is going to be the expression for the total distance. Well, what is this going to be? Well, this is going to be equal to the integral from 0 to 1. In the last part of the problem, we already have an expression for our speed. Our speed, we saw, was this business right over here. So it's going to be equal to the square root, give myself a little bit more space to work with, it's going to be equal to the square root of the x component of the velocity, cosine of t squared squared, let me put that little other parentheses there, squared, plus the y component of our velocity squared, the rate of change of y with respect to time squared. So plus e to the 0.5t, that's the rate of change of y with respect to time, or the y component of velocity. We're going to square that. This is our expression for our speed as a function of time, and then you multiply that times dt, and we're going to integrate all of this, and this is going to give us our total. This is going to give us our total distance. And lucky for us, we can use our calculator in this part of the AP exam. So let's evaluate this. And so let me turn it on and let me clear out. And so we're just going to evaluate. Let's go to math and function integral right over there. That's for evaluating definite integrals. And we want to evaluate the square root, I'll put an open parentheses, of, I'm going to have a lot of parentheses here, but let's see if we can do it. So the square root of cosine of, and I'm going to use x as my variable of integration, cosine of x squared, so that's that parentheses, I need another parentheses, squared, plus e to this business squared. Well, this we already saw before. This is the same thing as e to the t, right? If we raise something to the 0.5t and then we raise that to the second power, 2 times 0.5t is just t. So I can do that if I like. I could just type in all of this business if you like. So plus second e to the, my variable of integration here is x, e to the x. So close that. And then I close my square root. See, did I do that right? This closes around the x squared. That closes with that. Yep, okay, that looks right. And then my variable of integration is x, and I'm integrating from 0 to 1. And now let's let the calculator munch on it a little bit. And I get approximately 1.595. So this is approximately 1.595. The total distance traveled by the particle from time equals 0 to t equals 1, which is kind of neat that we can do these things just from the information that they gave us at the beginning of the problem.